Developers build the future. We take ideas and make them real. My job is to think, create, and solve for a living.
Each step we take is possible because someone asked questions. Why do we have to do it this way? What if we did it that way?
Each step I take enables people to go further.
Be creative. Change something. I'm working on blockchain that will change asset identity.
Artificial intelligence to automate homes.
Autonomous robots to improve efficiency.
My app is advancing human rights.
I build things to help connect people. Not everyone gets to build their passion. We share what we know. We share what we do.
Try, learn, try again.
Make, break, build.
Guten Morgen Berlin und willkommen zu Oracle Code. Mein Name ist Gerald Fenzel und ich bin der MC für heute. Thank you, danke. Ich habe gleich mal die erste Frage. Wir fangen gleich mit Teilnehmerübungen an. Soll ich auf Deutsch weitermachen oder auf Englisch? How many non-German speakers do we have in the room? Okay, a fair bit. Everybody cool if I switch to English? Alles okay, wenn wir auf Englisch? Yeah? Okay, great. That was already the first exercise, so that's good, you're all awake. Now, before we get our keynote speakers up, I just take you through a quick story, a little superhero story that you can hopefully all relate to. We're talking about how we as a developer can transform ourselves into a groundbreaker. And now probably people ask themselves, well, what is a groundbreaker, right? And this is exactly what we will go over with. So groundbreaker, or in German, neuen Grund erschließen, neuen Grund brechen, is all about going beyond where nobody else has been before. So going as a developer beyond where nobody else has been before with technologies of modern era. So when we look at our developer, the first thing we're going to do, we add serverless to him. Now, who has heard of serverless so far? A couple of people. Then you all know that this is not really the picture that serverless may sound like, right? It's not about throwing our servers away. On the contrary, it's basically a new way how we scale in a more economically viable means. Traditionally, when we wanted to scale, we bought servers, we brought them into our data centers, then we deployed our apps, and then as we put more applications on the server, we utilized them up to full utilization, and then we needed to buy a new server. Serverless is the different approach, or the opposite approach, where we scale by just paying by the time used on the server, and we don't have to worry about the hardware underneath. So it should look like a little bit like this. The traditional servers is those steps. We buy a server, takes a while until we fully utilize them. We buy another server, and serverless should theoretically give us this nice linear scale as we just pay more and scale more as we have more workload, not having to worry about servers. Now, serverless is available in various cloud deployments, but there's also open source projects, and one open source project that we're doing is called the FN project, which allows you to get serverless in-house into your own data center if you wish to do so, or run it anywhere else where FN is deployed or where you want to deploy it. We have talks on serverless later on the FN project as well, if you're interested in that area. So serverless is this one thing that gets us started really, really quickly. We deploy our code, and off we go, right? It's just deployed and off we go. So this is becoming our Jetpack, okay? So great, next thing we add is Kubernetes. Who has not heard of Kubernetes yet? Perfect, no hands up. I should ask the other way around. Who has heard of Kubernetes? Okay, people are awake, perfect. Good. So, well, I can probably go over this really, really quickly, right? The usual old school bare metal deployment. We have a server, we put applications on top. Then we came in and said, well, you know, let's use VMs because that gives us this flexibility of having of isolating our different applications, but we had this hypervisor and guest OS overhead on top of it. And then we added containers with a small container runtime, and that gives us some headroom back. That's great, But actually, let's talk about something more funny or interesting. When we talk about containers and Kubernetes, a lot of times we take this container runtime and the containers on top and picture them as ships. That's my attempt to draw a ship. Was never that good in art. But anyway, so we have our ship and we have the containers on there. And then, of course, once in a while it will happen, although we hope that it will never happen, but, you know, it's just inevitable that the iceberg comes, right? And then everybody says, well, jump ship. Looks a little bit like this. And, oh, come on, a little bit of a laughter. I know it's Tuesday morning. Okay, good. And of course, you know, so what are we going to do if you only have one ship? Well, you know, you're sort of screwed. So you want to have a fleet of ships or something like that. And this is where Kubernetes comes in. It allows us to exactly do that. It allows us, so our ships would be our servers and the container runtimes on top of that. And it essentially allows us to run a fleet of these ships. And if one ship goes down, heaven forbid, but you know, sometimes the server goes down, we would just move our applications to the other side as well. So Kubernetes allows us to deploy everything, and it just makes sure that, you know, it goes anywhere, etc. So it's a little bit like the Batman utility belt, where there's like always the right tool in the belt that you need to escape, right? So we're gonna put on the utility belt on our developer. Next thing we're gonna add is, of course, our digital assistants. That's how they call it now. Still a lot of people refer to them as chatbots. Little icon here like this when you draw it, or looks something like this, embedded into our messaging apps on the phones, where we can do various things like book plane tickets, buy flowers, whatever, via Facebook Messenger, via WhatsApp, and so forth. And we will actually talk to a chatbot on the other end. Now, they also come in this shape and form. Now, at this point, I always have to say, me as an IT person, I will never, ever put something like this in my house. It's already enough that my wife hears things she shouldn't hear. But hey, other people, go for it. And then they also come in this little cute form. They're Pepper robots. And they are quite nice because they look more like humans and you can talk to them. And we today actually have a Pepper robot here, just outside over there. So if you want to interact with a chatbot, if you want to interact with Pepper, then just go to her and ask her how she's doing and have a conversation with her. So digital assistants, that basically helps us to, you know, whatever we need to see, whatever we need to do, they help us to get there, and that essentially becomes the visor for our developer, right? We just, the heads-up display and everything there that we need to find a villain or similar. Next thing we add is, of course, blockchain, right? Everybody needs blockchain, no? Yeah? Like blockchain does not necessarily mean Bitcoin, although it is used for Bitcoin as well. Who in the audience owns Bitcoin? Okay, a couple of people, not that many hands. Well, I'm sure they are not that excited because this is what lately happened to Bitcoin, right? So it's like for all of you that do own Bitcoin, you basically were millionaires for a couple of, well, months or so. But if you missed that boat, then maybe keep hanging on and hope that it comes back up. But the blockchain technology actually underneath is rather interesting because it allows us to go ahead and put transactions into a Merkle tree where we hash together the block, the hash of the block, the timestamp, and the nonce, and then add it into this ever-appending chain of blocks. And the nice thing about it is it allows us to not tamper with the chain. So as we just added based on the hashes, you cannot go back in time and swap something out. And that is really, really nice to keep track of things, state of various things. Now, it sounds all very funny, but it's like, what does it actually mean? Well, first and foremost, we have to differentiate between a public blockchain, which would be something like Bitcoin or Ethereum and so forth, where we're all out in the open, everybody can participate in the chain, and then consensus is just reached by majority. But there's also private blockchains that essentially you or the participants make sure who can actually join and participate in the blockchain. Now, we actually found one really, really good use case that we have here today as well, because blockchain is like a lot of people still go like, okay, what is actually a use case? We actually used it to track ingredients for brewing beer, especially here now in Berlin, as there's awesome beer everywhere, microbreweries and fantastic, fantastic wheat beer. That should be really, really exciting. So we use this in California to essentially go with a little microbrewery called Acid Brewery. And they use the blockchain to track all the ingredients that they get from all the different farmers and so forth to brew their beer. even more exciting is that we have beer here. We do have the blockchain beer over there, so go and check it out later on. It will actually, I hope, open before lunchtime, we will see. So blockchain is the thing that can track everything we cannot tamper with. We can basically follow the footsteps of the villain. So this becomes the drone that flies ahead and the villain cannot escape the drone. And then next thing we want to add is, well, what every superhero needs, sort of a car, right? Like the Batmobile to get actually to the villain. This is where our autonomous database comes in, our cloud service that is self-driving, self-securing, self-repairing. Really, really great for just if you want to make sure you have a technology where you can store your data and rely on. Why? Because it's fastest time to usage, it provisions in seconds rather than minutes. You do not need any DBA necessarily, not only to provision it, but also not to tune it. It does it all for itself. And it's even more than just a relational database. It's a multimodal database that gives you JSON and spatial and graph and many, many more things as well. On top of that, we put a low-code platform called Apex, very well known in Germany. For those guys who don't write that much code but want to visualize data, you can use Apex to do so, and we have an awesome Apex talk here as well today if you want to hear more about it. To get started, you just need 6 simple questions. You push a button, off you go, your database is ready to go, and even has REST APIs on top of that. So that essentially becomes, as I said, the little car that we need to get to the villain. Now, we add all of this today together, and that becomes our Groundbreaker. And this is really what it's all about today. You will hear about all those cloud-native, latest and greatest technologies that are out there that help you to build the next generation technologies for your companies, for your users, and so forth. So thank you very, very much for being here. Now, that was basically already all from me, just the wake-up slides. Now we actually get a real expert up here on stage who will go deep and tell us everything about the future of Java. Please welcome on stage, big round of applause for Mario Torre.
Thank you. Thank you. Yeah, hello, Berlin. Ich bin froh bis hier zu sehen. Das ist eine wunderschöne Stadt und ich kann sagen, ich bin ein Berliner auch. That's all my German, so don't worry about that. No more German for today. I'm here to speak about, it's a little bit of an odd talk for a keynote. I'm here to speak about the future of OpenJDK, in the future of Java, looking a little bit at the past of it. So that's a little bit of what's on the menu for today. We are going to see a little bit of history of OpenJDK, how the project came into existence, and how then it works with its governance, with the developers and the stewards. So what is the project composition? And then we will finally explore JDK Mission Control and JDK Flight Recorder, which are the latest 2 bits being open sourced. And finally, we will see why that's so important. And just a slide about comparing with the previous situation when they were still closed. Then finally, I hope to entertain you with a small demo, and hopefully it doesn't crash, so I don't entertain you too much. So, who am I, first of all? So I work for Red Hat. I'm associate manager. I manage a team of about 10 people. I am part of the Java team at Red Hat. My team specifically works on Java Mission Control, JDK Mission Control, since the project was open source, right at the beginning. I've been working on OpenJDK for a very long time, basically before it was existing. I do remember working on, with some people here in the audience, on attempts of getting out of what was called, and likely forgotten in history, what was called the Java trap. The Java trap was essentially the problem that Java as a platform was proprietary software. At the time, with some restricted license, and there was no free software equivalent, especially problematic for free software distribution of Linux, because obviously there was stuck what had to be open sourced and free software. And most of the Java stuff was free software. The problem was the platform itself was closed. So that was the Java trap, getting developers using a proprietary JVM, even if they wanted to run a full open stack. There were some implementation. ClassPath was the most famous one. And the most important was a class library in itself. It wasn't a Java virtual machine. There was a number of Java virtual machines. GCJ, obviously, was ahead of time compiler. Caffe, JamVM, and yeah, you name it, many of them. Clean room implementation of the Java virtual machine. Then what happened? A night about, I think it was, don't remember exactly the day, but somebody was calling us on IRC on the ClassPath channel for a really huge event that was live streamed and then also on IRC with questions, and that was the Liberation Day. Java-C and Hotspot first, and then Sun announced that before the summer, the coming year, they would release everything else. There was a huge keynote of FOSDEM that year to announce that. That was very significant. The 8th of May 2007, that was Java Liberation Day. It was finally freedom. Java, OpenJDK was born, Java was free, the Java trap was finished. That's a quote from Richard Stallman. It's very significant from Stallman itself, the end of the Java trap. A friend of mine, Andrew Hughes, said, no, that's the problem here is going to be about building a community about this thing, because the code is there, problem solved. So this is how, what we are going to discuss today. We will see this journey and how this community evolved and how it worked out and how it is about. It was a little bit of a bumpy ride. This is the ClassPath mascot with Duke, you know him, going celebrating Christmas somewhere. Okay. So what is the composition of the project itself? So I want to thank, first of all, Mark Reynolds for these ideas. He had a very nice presentation of FOSDEM. This is online. I really would like you to go and see it because he's speaking in more details about how the composition is done, so the difference between developers, stewards, and governance. So I will only touch briefly on that today. So there is the community is structured in a way that all revolve around the developers. So the developers are the key for the OpenJDK community. Everybody is a developer. They may be different interests about the areas of development. And some of those people tend to be a little bit more into some specific areas, and they want to have more collaboration on bringing the Java platform forward. That's usually when the stewards come into play. So a steward is basically a developer that has a very significant history of contribution, and they want to have those contributions to impact the future of the Java platform. Typically, stewardship is meritocratic, so it's about recognizing the contribution that the steward did, but it needs to be, there is a very high entrance barrier. I mean, everybody can be a contributor as long as he's there contributing, and then if he wants to be a steward, he needs to contribute more to be a steward. It's all about a meritocratic approach. Then there is the governance itself. This is a legislative body. It's not an executive body. That means it doesn't have really anything to say about the inside of specific projects, but it has to say about how this project structure are being accounted for, what is the structure has to be about, and how the various legal things about project had to evolve. There are two components of the governing board. One is the at-large seats. Those are typically chosen by the community and by vote of all the OpenJDK members. And in the last few years, well, since the beginning, that has been Andrew Haley and Doug Lee. And then there are the stable members. Those are not chosen by the community. They are appointed by Oracle and by IBM, and they are basically George Staub, John Duymovich, and Mark Reynolds, and they are stable seed. The community evolved through years. At the beginning, there were a lot of problems, right? Yes, the SourceWorks was there. There were binary plugs that you had to put into the OpenJDK in order to compile. So the Java community started working about liberating those extra bits. At the beginning, it was difficult, and then it was less difficult, and then it was still less difficult. And finally, there was the problem about compliance, and then the TCK compliance came into place, and there is a licensing for OpenJDK. Then there is a problem, because the JSR was still a little bit too close, and so how to contribute to this process and make sure that new libraries and new framework will get into the OpenJDK, integrated new features added and so forth. And then the JSR process was slowly liberated as well. Now today it's a lot easier to contribute to the JSR. But then again, it was still a little bit too much for a reference implementation to go first to the JSR, and there was a need for testing feature and to make some experiments and then proposal and see the implementation that had to be in the open, and so the JEP system came into play. And the JEP system is a very interesting way of proposing features. Sometimes they can be experimental, sometimes they just get scrapped altogether from the build. But the JEP system makes sure that those features get into their way in the reference implementation, and so that the JSR that takes care of well, a little bit more than rubber stamping, but it's there to ensure that there is a compliant framework for the JDK. Then you can say, okay, those JEPs are in the reference implementation, so now we get them as an official exactly, it's an official OpenJDK version. Then I'm talking about reference implementation. That implies that OpenJDK has been the reference implementation of Java for quite a long time. I think that was really shortly after the beginning, in fact. Java 7 was the reference implementation already. Java 6 is a little bit different because if you remember, OpenJDK 7 wasn't out yet when Java was liberated, and that was the version in development, but JDK 6 was already out. So what happened is that the community backported feature from JDK 7 from OpenJDK 7 to create what was the JDK 6, and that's the reason why it wasn't the reference implementation for 6. Then there was the issue about bug database. Back then, that was a pain point for a few years, actually. FOSDEM, I remember the long discussions about that. There was no easy way for the community to start contributing bug fixes and see what to work on. It was all behind the old Oracle, the old Sun bug database system. So the OpenJDK community started to work with Oracle to host a server for a Jira instance that could be used for the Open Bug Database. So much, in fact, now, that if I'm not mistaken, this is actually the system that is used also for the closed version, the Open, even if the gateway is still the bugs.sun, if I remember. Then there was the problem about security and vulnerability. How do we share patches? This is an hot topic because it's not really as simple as say, okay, I have a bug here that is going to destroy, I don't know, some billion of servers, and then I just send a patch on the OpenJDK mailing list and I get it approved. There is needs of some coordination, some secrecy as well. So this is how the security and vulnerability group, which is like the latest addition to the OpenJDK community, was born. Then there was the issue about what to do when we have older versions and we want to maintain them. We want to give a possibility to the current maintainer to basically step out of the maintenance work and make other people step in. So the OpenJDK community decided about some, still a little bit under discussion. I believe it was kind of fine-tuned in the latest months, basically, but it's still a little bit under discussion how exactly, but there is a way for new maintainers to step in and say, for the old maintainers to step out and say, okay, I want to pass over maintenance work. And then the most important aspect of all, yes, OpenJDK is a project, and every build of OpenJDK is a derivative of this OpenJDK, and this is what forms Java. There are proprietary builds, and those are from Oracle, and then there are builds that have to be open sourced because of the GPL license in OpenJDK. GPL plus class path exception, if you remember the first slide, you get a very nice in there. And so what Oracle did, at the end of the last year, I believe, if I remember correctly, was to decide that they didn't want to have any more proprietary build in the old sense. They wanted to release everything that was making a difference between the closest builds and the open build. And so they started to offer GPL builds to the community. They are builds of the latest version of the JDK, and in particular the version that Oracle is maintaining. And then they started to open source everything that was still part of the closed builds. That's kind of the topic of today's discussion. So I say every build of OpenJDK is in fact a downstream distribution of Java, and there are a few of them, vendor specific, some free software. Then there is the Oracle JDK. Obviously, Oracle JDK is here in this picture because it's being part of the community. It's one version of OpenJDK in itself. So there are lots of ways to get those builds. You can probably just type, if you are using Linux or version of variant of Fedora, you just get, I don't know what's the command today in Fedora because they keep changing those. It was used to be yum install or something. DNF, I believe today, is it? Too fast for me. Then there is the OpenJDK build. Those are interesting. It's a project that is offering builds for various platforms that you can see and test, especially interesting when for you it's difficult to get builds elsewhere. For instance, they are offering for Mac OS and things like that. Then there are Sub, Azure, Amazon, lots of contribution from the community. This is very interesting. And in order to differentiate a little bit this offer, then what happened was the introduction from Oracle of the idea of having long-term support releases and short-term support releases. This is not something that is part of OpenJDK, however, because from the OpenJDK point of view, every release is just the release, and then it stops being the release in the moment that there is no maintainer maintaining this code. It can be Oracle, it can be Red Hat, it can be anyone else. And in fact, there are a few versions of OpenJDK that are currently being maintained, and they are considered a little bit long-term support. OpenJDK 11, 8, and 6 are all being maintained, and the current version is 12 with 13 coming soon, I believe. I don't remember exactly the dates. So you see, there is a really very wide ecosystem that is built up around the openness of the JDK. Now, I want to thank again Mark Rhino for this and the next series of slides. I asked him to send me what are the JEBs that the community is contributing to OpenJDK. And this is the list, and you see it is really comprehensive list. Highlighted in yellowish are the contribution of the community non-Oracle. Everything else is the community Oracle builds. So this is for the Java 9. It's really a long list, obviously. Then faster release cycle means a little bit less feature, more time to standardize on them. And this is again for Java 10. You see a couple of features, JEBs contributed by non-Oracle members, and the rest Oracle as well. Here as well. This is the list for Java 11. We have another garbage collector. This is Epsilon. And I believe that Shenando has been also integrated in 11 at this point. It's part of the, or maybe it was in 12. Maybe, yes. Exactly. I have the slide here. It's in 12. So Shenando is part of, and this is a garbage collector contributed by the community, in particular by Red Hat in this case. That is part of the standard distribution of OpenJDK. You download the sources, you build, and Shenando is there. This is the link for the binary builds I was saying before. Again, the binary builds are not part of the project in itself, so OpenJDK doesn't really give binaries. Those are courtesy, in this case of Oracle, for the 12 builds. So overall, what is important about all this, this message is basically that the Oracle stewardship helped opening the Java platform. And the level of competition in favor of something that is more important, adoption and collaboration. There is no one single entity that can do this all by itself, and this is why adoption and collaboration are so critical for the future of the Java platform. And of course, a fast release schedule may mean some disruption in some people, but the important part there is to always understand that faster release cycle doesn't mean that the version that are not long-term support by any given company are lesser good or they are beta versions. This is a common misconception that is important to overcome. They are all very stable, and that's the main reason why we have this faster release schedule for them, is in order to encourage more participation, get the time to do the feature right, and have more time to give the feature to the community, to the community of users in particular. And that's also something that happens within the community itself. Every collaboration on OpenJDK is a community collaboration. And of course, there are companies like Oracle is giving a large number of patches, and it's also have a large number of developers working there. So obviously it has a little bit more weight in some of the things. But when it comes down to the community, everybody is really equal as long as there is a contribution. Now we get to the point of today. So there was a little bit a missing piece in this picture. It was all very, very well and done, but there is still something missing. OpenJDK as a platform never really had a proper tooling, even though it had some support for your agent, for instance. Never really had some proper tooling to get analysis of how the behavior itself of the Java platform is, or the Java virtual machine, or some of the libraries that you may use. So there wasn't a standardized way. There were a large number of tools. Some of you can recognize that the picture. That's just a sample of the alternatives, like Visual VM. There's Thermostat. Selfish plug here because I've been working with Thermostat as an analytic platform for the JVM for the last few years. Flame Graph that used in conjunction with Perf, they allow you to explore a little bit more of the data, so what happens inside the Java virtual machine without the trickery that the instrumentation does to you, because the Java virtual machine likes to lie to the users about what it's really doing under the hood. So once again, there were a few things not standardized, maybe using some standardized API in the serviceability project, but not really part of the JDK, and there was something needed that was part of the OpenJDK. Sometimes you had a problem with, those monitoring platforms that incur too much overhead, trying to get, for instance, getting app dumps and trying to analyze those app dumps. This is really a killer for performances. Or tracking object usage in maybe real time. If you try, this is going to be really fun. And sometimes to overcome this, they would be trading just a little bit of accuracy, maybe too much of that. Or they were too specialized. And so users had to start using a multitude of those tools in order to get their job done. With the introduction of Flight Recorder, most of those problems were fixed right at the beginning, because this is a JEP, so it's an official API. It is part of OpenJDK. It's integrated in the Java virtual machine, so the VM knows about the events. That's important even when you are outside of the scope of the JVM itself, thinking about Growl, for instance. Should not name it that here, but anyway. The events are part of the JDK, as I say, and they're designed to be efficient. The way that we use events in the JDK is designed to be extremely low overhead. Even when enabling a little bit too much of them, the overhead can still be accounted in about 2%. Of course, you can always do worse and start analyzing every single thing, and then the overhead grows, but overall it's very efficient. There are extensions for the API. There are Java extensions, and they are living in the JDK.Java Flight Recorder, JFR namespace, so you can start instrumenting your application. We will see a demo of that shortly. Then finally, this was all open sourced in OpenJDK 11. That was really a big part. It's part of the serverless API. However, Flight Recorder has been developed by the hotspot people. Feature are added every time, and it's very well maintained. That's an example of the API. In order to define an event, all you have to do is to get a class, extend the event from the JDK.jfr namespace, and then you have a bunch of notation that you can use in order to help the tooling, which is most probably mission control, to visualize the information. You can give some meaning to the data. You can say this is a string, is a message, it's a label. So this is mean for labeling something. But it can be something like a double, a number, and then what it is that this is a quantity, or maybe a frequency. So there is a large number of APIs that you can use to define correctly what is the event. And then in the moment that you need to commit the event to the event buffer and then to the flight recorder eventually, it's simply about one method call, which is this commit here. How do you read those events? So the way flight recorder works is that every now and then, and that's something that you start configuring from the command line, it starts writing the events on a file that can be used by some application. It's a binary format, it's very efficient as well. And the units of events that the flight recorder has is called chunks. This is about the smallest things you can have, but all those chunks then form the large flight recorder file. You can keep asking flight recorder files. And again, there is an API in the service a bit, and we will explore that in a few minutes. This is code. These events are being read user. There is also tooling inside the OpenJDK that does a little bit of analysis, but the best way to collect those events and understand them is by using the tool Mission Control. It was also open sourced last year in May 2018. Mission Control offers a lot of APIs as well. So it is possible to use part of Mission Control without using the full Eclipse-based IDE in order to create your own applications that are that are using the API and can start monitoring and doing performance analysis without the full IDE. So maybe from command line, server-based, serverless, as we've seen before. So having a multitude of different deployments that don't have to be necessarily on the user desktop or the admin desktop in an old-fashioned way, but they can be in the cloud, for instance. Mission Control was open sourced. We started contributing right at the beginning, and we have already RHEL, VSCL, and Fedora releases So it's possible if you're using a Fedora derivative like CentOS or Fedora itself, you can start working on that right now, and there are packages. On the other hand, there are also builds available on java.net from Mission Control. Those are preview builds, however, because officially the project is still not being released, and I'm really looking forward for the official 7 release that was supposed to happen in December. For some reason didn't yet. Again, APIs, I say. So all that can be done by the IDE or by the, the standalone Eclipse-based application, but it can be done by your application as well. This is the smallest self-contained example that can read a flight recorder and then create an HTML report out of the recording. This is using some interesting functionality that gives a hint to the developers about issues that they're present in the code without doing any analysis manually. So you don't have to look and see what is the memory consumption to see if there is a memory problem, because the report is pointing you to a memory problem already. If there is a garbage collection issue, the report is going to tell you, look at the garbage collection because this is a problem right there. And maybe it's also suggesting how to correct in some cases if there is an issue with I don't know, network transfer as well. Again, a little bit more complex example. I don't think I want to go too deep into that. It's just about explaining some of the API. In this case, is for creating aggregate reports based on average standard deviation of some metrics that is part of the Java recorder, the Java Flight Recorder file that is being triggered. One more thing about that is like to say the API is very interesting. It's really a Keynote the streams. Maybe if you go back one step, it doesn't, even if it's not targeted at JDK 8 and below and beyond that, you can still use that with JDK 7. And I believe in 6, but I don't want to be, this is quoted on that because I didn't really try that. It's very similar to how you will do analysis with streams. So you rarely access the single chunks. Actually, this is very discouraged. And what you generally want to do is to get averaging reports, so analysis that encompasses the whole range of data. I was saying before, there is a little bit of significance here. Why Java Mission Control and Java Flight Recorder, JDK Mission Control and JDK Flight Recorder have been open sourced, and they're very significant for that. Java has been a really long time in the opening now. We've seen that at the beginning since 2006. But still, some parts kept growing in the closed world, and they kind of get this interesting thing where Mission Control Flight Recorder for a long time was considered to be the value add of having a closed version of the JDK. So this is something very important and significant Oracle did to open source this last bit, so to totally level the field. There was a little bit of work there at the beginning. I think in Java 11, an events API was introduced. It was mainly for making it easier to backport patches between Flight Recorder and the main line, but it wasn't enough, obviously, because that was something that was never really used by the community, and at large, it was only used by Oracle specifically for easy backporting. That until 11, but not anymore. So when 11 was out and Java Flight Recorder was finally there, this is where things changed. And it wasn't hidden anymore behind a restricted license. At this point, you can avoid using the allow commercial feature, and this is there in OpenJDK. Whatever distribution of OpenJDK you are using, this is okay to go. Check the license. The community engagement was very high from the beginning. We started to schedule calls with Marcus here. This is the project lead. It was, I think, at the beginning almost on a weekly basis. Over time, a little bit less than that. Anytime it's needed, though, there is a call. We have a multitude of channels for communication. There is the IRC that we helped setting up at the beginning until we kind of migrated to Slack, but IRC is still there if some of you, like me, prefer the old systems. Then we started sharing bugs and backlogs. So for instance, what are the features that would be nice to do in the next version? And this is something that is one of a kind. OpenJDK is doing that already now with some of the features and the JEP process. But this is the first external project that is still kind of in this environment of OpenJDK that is so comprehensive. It never really happened before. We have OpenJDK backlog for Java Mission Control, or JDK Mission Control, forgive me. And there's been a lot of collaboration externally already. When externally, I mean not Oracle community members. There have been a lot of contributions, some from Google, other people, some standalone developers, some other companies, and obviously Red Hat has started to contribute very heavily, and we are kind of accounting 1/3, last time I checked, maybe a little bit different now, of the whole contribution to the project. So we really evaluate this a lot, and we wanted to jump on that and share everything and all our knowledge to improve that. So kudos, Marcus. Really, really awesome. Thank you for doing this. Check out this blog. There is a lot of information there for how to use Mission Control and Flight Recorder. So now the demo that I'm hoping it will work. Otherwise, I promise you to be entertained today. So first of all, I just have to get out of the presentation. Yes. First thing first. So this is how Mission Control looks like. As you see, it's very boring at the beginning. There doesn't seem to be a lot of stuff happening. There is a classical ambient server. This is very similar to what you find in tooling like, I don't know, Visual VM and something. So it's not very exciting. There is a little bit of stuff going on there, but nothing really, wow. But it's interesting because you can start, so with Ambient, you can start controlling the behavior of the virtual machine. So it's significant that it's there anyway. And we will see later an example. And then you can start getting the recording. How a recording looks like. This is the, yes, we want to do the automated analysis. This is the very first page that you see. And if you're using the API that I showed before about creating a report, this is what it does. You can click around and it sends you to the right page for where the action is. And then you can see, okay, there is a little bit of biased blogging going on, and there is an explanation of why it is happening, where it's there, and if it's a problem, you should look at. Then it gives you direction to where to see the project. Thrown errors, obviously there is a lot of errors that are normal in the JVM initialization, but the tool is smart enough to understand most of those situations. So it can tell you if this is something that is particularly high but is to be expected, or if it's something that you had to take care of. Okay. Then let's go to the problem at hand. So this is a very silly demo that I did today. As you can see, I'm not a developer anymore. What happens here is that there is a robot shop, and there is some kind of place where those robots are being created. In reality, this is just junk. It's just objects that keep being created. And then there is, the shop is asking those robots to be sold. The problem is that the robots are really, creating a lot of them. There is a little bit of delay, which is not really a smart way of creating robots and trying to not have too many of them in your, parked there. So this is not really a way to control production. But this is how the developer did that. They weren't really very good. And so the problem is that now this demo is creating a lot of robots, And the code that is consuming them is also not very smart. It's just leaving a little bit, and then from time to time, you say, oh, I want to have the next order. So what happens here is that there is a very big discrepancy between the number of robots that are being created and the number of robots that are being consumed at any given time. And you can see that from here. Like it keeps growing and growing and growing and growing for forever. That's a problem, because that means that you have in production a lot of robots that just have to stay in a warehouse until somebody buys them. That's not really efficient. But luckily, the developers, we didn't have any real protocol in order to give this information. They were using Mission Control to get some statistics. And that's what they did. They finally got an event for storage requests. And the events always say, okay, what is happening here? How many robots do we have at any given time, and how many robots we are selling? The selling is a little bit silly, just always one every request. This server is very important for the company. They cannot take it down to amend the code. They don't have any more developers for doing this kind of job. So this is really critical. So they hired a guy that knows everything about Mission Control. And what he did is say, okay, what I can do, I can use the Mission Control API and do some magic there by getting some statistics, very simple statistics. You know, I mean, this is really simple. If there is, I'm just getting the events, and I'm trying to get how many of those robots are being created every now and then I try to slow down, which is the only thing that the API gives me possibility to do, the production based on the number of robots, so that I can kind of equalize the number of robots. And now this is a really high number, so this is going to take forever to do that, but I will show you anyway in production. With the number of robots, so what is happening here? Remotely, we are asking, so this is over the network, even if it's all local, obviously, on the system. Remotely, we are asking for a flight recorder file. And this is done here. It's using all the standard Java API. There is nothing really special on that in the management. So the management bin is asking, is attaching to the VM. It's using standard API. This is OpenJDK 11 modules compatible. It's connecting to the service URL via JMX, and then it's asking for the MBin that is the Java Flight Recorder MBins. And then it's asking for a recorder. You create a new recording by asking an ID, and then those ID can be stored there, and then you can ask the recording anytime. And then it's saving it to a file. This works over remote, so the transfer is actually over the network. And then the file is stored. Whenever this file is there, the robot is here. It's reading the file, and then it's analyzing it. In this case, we only use an aggregate quantity. We want to have the average of the events that we created. If you remember, in the logging, this is the event itself. So basically what we're doing is to get those fields, we're reading them, and then we try to get them closer to 1. This is a very simple, I mean, this is not machine learning thing, anything, it's just a division. But eventually you can do something more interesting over there and start using machine learning to get proper difference between the production and the consumption, and try to get a minimization problem over that. So this is a silly example, but in fact it can be used in real life. And yes, what is happening here is that you see here, it's basically increasing the threshold. The threshold is the delay that we saw at the very beginning, which is here. So this is the threshold. We started with 100 milliseconds, and now it's about 3 seconds something. And then it keeps going until it reaches a point where things are a little bit stable, and then it will start increasing and decreasing this delay again and trying to optimize. That's all for today, for the demo, at least. And, oh no, we have questions coming, I guess, in 3 minutes. Yep. Some questions? No questions. We have 3 minutes to spare. This is magic. Okay, just hop on the project mailing list, get your stuff, contribute, see the demos. We're preparing a lot of stuff. In the future, we are hoping to get more code out in the wild and make more use cases, for instance, in a cloud environment, which this is extremely useful. Done. Thank you. Thank you.
Thank you, Mario.
Thank you
very much.
Thank you, everybody at Oracle, for hosting me.
Okay, is this on? Yeah? Okay. Can you hear me? Yeah, okay. All right. So, as Mario took us through the future of Java and Mission Control and the details of OpenJDK, it is now time to actually talk about why it is, click it out, there we go. Why it is the golden age for developers. Our next keynote speaker, wrapping up here, is Bob Quillen, Vice President of Oracle Developer Relations, and he will take you through what a cloud-native platform looks like and why it's great to be a developer again. Please give a round of applause to Bob Quillen.
Am I good? Yeah. Right.
Okay. All good? All right. Well, welcome, everyone. It's great to be here. I'm Bob Quillen. I'm the Vice President of Developer Relations for Oracle Cloud. And pretty exciting discussion today. It's a topic that's near and dear to my heart and something we've been talking about at Oracle Cloud a lot since probably around KubeCon, the big Cloud Native Computing Foundation CNCF conference in Seattle back in December. And we've been building on that set of themes around what's happening around the culture of development, DevOps in particular, what's happening around open source and cloud computing, containers, microservices, Kubernetes, a lot of things to dig into there, and what's kind of happening around cloud. But all these things come together in some really interesting ways. We're at a golden age of development, you might say. It's a great time to be a developer with all this democratization of the open source technology. We've been seeing a lot of that with the Java discussion going forward. A lot of the stuff you'll hear the rest of the day digs into a lot of those topics. So I've been with Oracle over 3.5 years now. I came in as part of the Stack Engine acquisition. We were an Austin-based startup doing container management, sort of the early days of Docker container management. And we've been following the wave of cloud native around Kubernetes, et cetera. And so talk a little bit about that history too. So why don't we jump on into it. The 3 C's we'll be talking about today really focus on culture and what's going on with DevOps, the value of DevOps, and then some of the challenges that are going on with DevOps. You see DevOps morphing into a lot of different things over the last probably 3 to 5 years, including site reliability engineering, SRE. We have a discussion on that from some folks from my team later on today. Around DevSecOps, we bring security in, AI ops, no ops. But all these things are really trying to do is bring Dev and Ops together and create a better software lifecycle. So we'll dig into that a little bit. Also talk about open source, what's going on with the Cloud Native Computing Foundation, containers, Kubernetes, and kind of what comes next after that. Some of the challenges around this open source, particularly we've seen over the last 3 to 4 years, even 1 to 2 years. This stuff is happening right now, how people are using these container technologies and how the cloud providers like Oracle are providing managed services that can help you sort of leapfrog through all this complexity. And then we'll talk about cloud itself, some of the challenges, and how the culture and the code and the open source community can help drive how we use the cloud going forward. So, one way to look at sort of the history over the last 30 years of application development is kind of look kind of across 4 different major factors that form maybe 3 epochs that have occurred and help to drive application development forward. About 30 years ago or so, we had a waterfall approach that helped build monolithic applications. We deployed those on physical servers into data centers. Those 4 areas work together And a lot of those applications are still running today. Many of us are probably still managing those applications. I helped build some of those in the early days of my career. And when I talk to customers today, a lot of Oracle customers, these are some of the mission critical applications that are still running today. But we transitioned probably in the last 10 to 15 years into something that's more agile, something that uses more distributed computing technologies. We started looking at client server and then moving over to end tier, deploying those to virtual servers, this whole virtualization movement, really driven by VMware itself, and deployed into hosted environments. Each of those four components really drove that next phase and sort of the previous phase to what brought us to where we are today, which is this transition into a much more DevOps, lifecycle-driven development process, which is building out microservices that can be run in containers. So we've gone from physical virtualization, server virtualization, now into application virtualization. We kind of work our way up the stack and finally deployed out to the cloud. And what's kind of interesting is you look across the board, each of these kind of help to build out and amplify each other. So each of those components in the phase really help define that movement, how we develop, where we develop, the architectures, the deployment models, et cetera. But they also help define what are some of the challenges going forward. And you kind of look at going from each of these transitions. How do we take teams that have been using more waterfall and agile approaches going to more DevOps approach? How do we go from a virtualization model that was server virtualization, something more container-based? Microservice architectures, very different from a previous set of architectures. Microservices kind of being driven from the big cloud providers and the cloud scale SaaS vendors, the Netflix, the Googles, the Ubers, et cetera. They're all using the microservice technologies in the cloud for containers, et cetera. So we're at the place now, I think we'll talk about each of those in the next set of slides. So my personal journey kind of followed down that set of trends too, and I've been in a variety of startups and large companies that started off managing. I kind of worked my way up the stack in a similar way. I worked up from the network management SNMP era with NetLabs. Packeteer was an application monitoring solution at the network level. Worked our way up into more of the EMC end layers and Hyper-9, which is the virtualization era. So a lot of that was managing and automating and orchestrating virtualization systems. And then moving over to cloud and container-based technologies. I'm based in Austin, but I spent 20 plus years in Silicon Valley, done over 10 startups, lots of different acquisitions in that process. So hopefully that gives you some background. I've done software development in a whole range of functions now inside startups. And that's kind of how I got here and kind of give you a little perspective of where I come from in the context from which I speak. So let's jump into DevOps for a little bit, and some of the value of DevOps and how people are using it, and some of the research that's been done. We talk about Dev and Ops, cats and dogs living together, mass hysteria, anarchy. But really the whole idea is this is supposed to bring harmony and sort of integration into how we develop. Instead of throwing things over the wall, Dev throws it over to Ops and they're supposed to catch it over the wall. This is actually a continuous life cycle with CI, CD, et cetera. So really culture and DevOps working together, providing this next generation going forward. So what are some of the key benefits? And if you've ever had a chance to look at the State of DevOps report, I don't know has anyone ever looked at the State of DevOps reports? They come out every year. You can Google it. It's very complex research. Thousands of practitioners are interviewed. It's a statistical survey looking at the practitioners and what makes them more successful than some other practitioners, and trying to look at different groups that are being successful deploying DevOps. Some of the value points they're getting are over 200 times more frequency of deployments, faster deployments. When you make changes, the changes are managed much more quickly, and the failure rates are much lower. So each of these statistics kind of break in the survey low IT performers into one group, medium IT performers, and then high IT performers. And you kind of can see the difference of how they grouped these teams together and how they're using DevOps technologies. Deployment frequency going from months to weeks to days, or actually multiple deploys per day to the highest IT performer. The lead time for changes, how long it takes to do a code commit to actually have that code running. 1 month, weeks, down to hours. Mean time to recovery. When you have a problem, how long does it take to recover from that problem? Days to hours to actually less than an hour. So you kind of can see these cohorts breaking into some really distinct patterns of success. These are not only technical successes, these are business successes too. You're able to get product out faster. You can be more competitive. IT and software teams and application development teams are more able to respond to business situations. So DevOps is actually a business driver and a technology driver. But also, in some of the more recent surveys, they started looking at the people benefits. Teams using DevOps technologies are actually happier. They're working together better. They're more than 2 times likely to recommend their place of work than someone that doesn't use DevOps technologies and approaches. They spend less time doing crappy work and work they don't want to do, that unplanned work and those failures that occur. So you actually have people benefits, more exciting workplace. If you're using open source technology, if you're working with a broader community, you're able to recruit more people into the company, and then the people working inside the company feel more not just part of the company itself, but part of a broader community. And that's one thing I think that the open source community has built is a broader community that spans across companies and creates a more democratized access to these technologies. So they also looked in these surveys, they analyzed what are the patterns that makes these DevOps teams successful, right? So automation being one of the key patterns of success. And that automation occurs in terms of testing, in terms of deployment, in terms of integration, CI/CD. And you can kind of look again, the performers that are low to medium to high groups, the difference between the use of automation and not using automation as part of that. So automation being another key aspect of what makes teams successful in using DevOps technologies. And I found this one kind of interesting too. This is kind of a, they call it a structured equation model. And the outcomes are on the far right here, but then they work backwards to figure out what are the components and conditions that are used to make DevOps most successful. So if we want to get high IT performance, lower deployment pain, what are the leading patterns? Lean product management was one of the areas they saw was a component of teams that were being successful. Not just the development team, but the product management team that's actually helping to define the product. They have to work very quickly and use these quick life cycles and respond to those. The product management team has to be part of the process too. So it's not just developers that have to change. Product management teams have to change too. And that was a key observation. What are some of the technical best practices? We just talked about automation, continuous integration, CI/CD, kind of obvious. One of the things that's also interesting, shifting left on security, the idea of getting security earlier in the process. So sort of the DevSecOps movement that's going on right now. And then finally, look at what is one of the key first drivers that makes all this stuff possible is leadership, transformational leadership. People actually being driven from the top down. So it's not just a bottoms-up problem. It's not just a bunch of developers that have to fix this. This is a top-down commitment. It includes the full team, the engineering team, the product management team, the executive team, and the development team. So this is a comprehensive change, and that's why it's so difficult at times to get this cultural change to happen across large organizations. But there's patterns and there's well-known approaches to do that, and we'll talk a little bit about some of those too. We just talked about culture and DevOps, so we'll talk a little bit now more about code and open source. And any Mr. Robot fans out there? So Mr. Robot, the democratization of open source technologies is a great way to look at how the Cloud Native Computing Foundation, a lot of the open source work that's been going on most recently is driving this next generation of tooling and software development forward. Stack Engine, my startup, kind of started back in the early days of Docker and container management. And a lot of the first phase of Docker and container adoption was focused on the developer itself. And this is probably about 3 to 5 years ago. I remember going to the first DockerCon. It was in San Francisco, like 2014, I think. And it was like 500 people in a small hotel set of rooms, probably smaller than this environment here. Now we have KubeCon happening in Barcelona. I think it's going to be 14,000 people. It's going to be a huge kind of next celebration of where we are going forward as a community. But Docker did a great job about creating an environment where you can actually learn and get enabled as a desktop developer. And they got millions and millions of desktop developers using their Docker development environments. And that's kind of what Docker did. They moved the industry through this first phase, focusing on dev test apps, simple orchestration, really getting everyone trained around that. But once people started developing code, it became applications. And that's kind of where Kubernetes came in. You have to orchestrate those containers and those microservices. You have servers, we have things we have to deal with, we have cluster management, more operational challenges. Not just developing it now we have to deploy it at production levels. And that was that next phase. And that's kind of where we are right now, this DevOps focus. Kubernetes is now the focus area. It's kind of, we take a look at DockerCon and KubeCon. KubeCon has kind of taken over a lot of that technology and a lot of that kind of emphasis around containers are an assumption, is almost the plumbing now. Now how do we manage that? And Kubernetes is now going through that acceptance phase too. And we're looking at what happens next. And what happens next is this whole sort of end-to-end model. We're bringing this all together. There's more managed services, so you don't have to do it yourself anymore. There's more focus at what happens after Kubernetes. So as we go up the stack, we're going to start talking about serverless. We'll start talking about using service mesh and using other types of technologies of how you manage and monitor. What's the tool bench that you access to manage these new applications? People are talking about DevSecOps and machine learning. Those end-to-end integration of all these components. It's a natural kind of migration. We saw this model happening back with virtualization. It's a very similar virtualization adoption phase that was going on the server virtualization, as now we're seeing kind of with the application virtualization and containerization world. Okay? So the future is really open. We at Stack Engine back in Austin, we started a bunch of meetups. We started with the DevOps meetup, and we had a Docker meetup, and then we started the Kubernetes meetup. And you kind of, all these organic meetups really was how everyone got trained. We all learned about Docker, containers, Kubernetes, et cetera, through the meetup community. And everyone should actually, I'm sure there's meetups all over the country here. And that's a great way to learn from your peers, from experts that are coming in. And it's not only experts that are coming in, but we also have a lot of beginners and people learning, who are traditional developers from different technologies. A lot of people came in, and that's how this whole thing got started. The idea of having unforked open source technologies that are really driven around this cloud native computing foundation approach. It really encourage folks to get involved in the community, to learn, to engage. And that's, I think, one of the benefits that I've seen in particular is that it's not just vendor-driven, but it's developer-driven, it's community-driven, and that's a different way of actually learning and creating a whole kind of new wave of support. So, another interesting kind of observation, I dug this slide out from a few years ago, and it talked about containerization is based upon a survey actually Docker did in 2016, so 3 years ago. And you kind of can see that the early days, quote unquote, of containerization, the use cases were mostly around development, around CI/CD, kind of in that early phase we talked about, developers using it for productivity, for CI/CD, for dev test, et cetera. A lot less around refactoring legacy apps or building out new applications and microservices. So that was in the 20 to 30% range. Most of the focus was around things I could do as a development team, create my development lifecycle, some DevOps use cases, et cetera. Fast forward a few years later, in one of the most recent surveys from the CNCF, we see development and test and kind of POC work, still very strong, but you kind of look at the production ramp up here. Production is really growing in terms of how Kubernetes containers and Docker are being used. Being used across public cloud, on-premise, and private cloud environments on a fairly equal basis. But this rise of production is indicative of where we are as an industry around cloud-native computing. It's a little bit of an eye chart, but the darker purple adoption slides kind of show which projects within the CNCF are getting more and more focus over the last. This is just from a few months ago here. And it shows not just Kubernetes being a really key technology, but also technologies like Prometheus for monitoring, logging, tracing, kind of what you need to do from a production standpoint to manage and monitor and trace and log. So it's not just a matter of deploying it, but it's also now managing it. And all those projects are getting stronger and stronger adoption across the board. So also indicative of where we are as an industry. We're not just developing it, but now we're actually building out production applications. So we talked about culture, we talked about code, now we're going to talk about the cloud and the power that can provide you. A little He-Man and She-Ra. So it is pretty amazing of what we've seen, and even you take a look at the bare metal cloud, Oracle cloud, and what we've been able to provide just over the last couple of years. Incredible leaps in latency and CPU and I/O, IOPS, high availability, all these things providing this incredible basis of cloud power and technology. If you think of that technology and that power and open source software running on top of it, it's a huge win-win. So we can develop anything we want to. With technology, we can actually get free at home and use on weekends and try out. But you can also use that now in production at work at very large scale, because that's where those technologies came from. The technologies from open source and CNCF were built and run and tested out in these major cloud environments, major cloud providers, and now built to run major applications. The selection and kind of variety that you can get in terms of the shapes and the patterns for your compute is also broad. Very simple ones you could use for just building out web applications. You move out to more dense I/O, all the way to stuff that you can run big data applications, AI, ML applications, containers, et cetera. So this variety and the choice you have from very small shapes to very large CPU shapes is also just almost mind-blowing if you think of that choice wasn't available 3 to 4 years ago, but now as a development team you get access to that like that. But also not only compute, but various types of storage, various types of database technologies, all that automation, all that technology is available to us. And we layer on our culture, our DevOps technology, our code, and now we have the 3 C's really creating this huge potential influx of what we can do this next generation of application development. So that's all great news. But as we all know, winter is coming. There's going to be new episodes coming up very soon. And there's going to be dragons. We know that. So there's challenges ahead in all these areas. And so let's talk a little bit about the challenges. It's not always good news. It's always like a big but. There may be some bad news here too. So what are the key challenges? So I'll go back to some of the survey information. Let's go to the data and look at what are the big challenges, the top 3 challenges. And this is from CNCF and their own surveys. Number 1 was cultural changes. What are the things that are affecting container usage and deployment? Number 1, development changes, cultural changes for developers. Second is complexity, and the next is lack of training. Complexity, lack of training, how do we transition? These are sort of the next wave of challenges. We've got all this opportunity, all this cool stuff, but how do we now take advantage of it on a broader scale, right? So, the way we look at it and the way we talk about it a lot within Oracle is that there's a kind of cloud natives at a crossroads. We need to get much more inclusive of how we look at cloud native. It's not just for unicorns and some of the larger cloud providers and cloud scale environments. This culture change for developers is difficult because on-premise teams, many teams are being left behind because the technology hasn't really provided an easy way to map that into the cloud native world. We're starting to see more and more of that, and there's tons of sessions today around serverless and Java and microservices and how we bring all those worlds together, which is kind of going to really enable this next wave where it's not just a small set of unicorn applications built in a pure greenfield, from scratch container DevOps world, but something that's much broader and brings a lot of these different more legacy or traditional or existing technologies together and brings them into the cloud native world. Complexity is really a factor of all this choice we have. I'll show a little later that big cloud native computing foundation. There's thousands, hundreds and thousands of different open source applications, and they come out all the time, and there's rapid release cycles, et cetera. So how do you choose amongst those? And then how do you learn that? The training is really hard to keep up with all that. And then since it's so hard to make the change, and it's so complex, a lot of people just use a single cloud because it simplifies my work. But it ruins everything. If you spend all this time going open source, building out DevOps technology, you built yourself a foundation of choice that you can run anywhere. So it kind of ruins the whole thing when you start looking at just using one cloud. So we think the future is a multi-cloud future. You could use it on-premise, you could use a hybrid cloud, you could use it in the public cloud, and use it across clouds depending on your use case. We'll talk a little bit about that too. So that first issue about cultural change for developers and the need to not think kind of excluding everybody, but how do we get more teams involved, more applications involved, more software platforms into the cloud native world per se, and how do we build on-ramps based upon technologies that we know. So one thing that I'll go through 3 examples, and the first one is we built out over the last probably couple years a WebLogic server Kubernetes operator. So the Kubernetes operator pattern allows you to run your application in a Kubernetes context, but within that same technology that you already know. So in this case, you can run a WebLogic application, and it maps the underlying operations and the orchestration to Kubernetes. And what we found is there's some very large teams from CERN in Switzerland. He has some great use cases that are up on our web you should check out. Verizon, a bunch of big companies have begun to transition over their WebLogic, some of the largest WebLogic applications over to Kubernetes because they want to take advantage of these new cloud-native foundational technologies, but they can't make that change and just rip and replace everything. So it's kind of a move and improve model of taking your Kubernetes application, your WebLogic applications, your Java applications, and moving those over. Take a look at the GitHub site there. There's tons of information about it. We've had several releases over the last probably couple years, and it's showing a lot of success in bridging the gap between the existing WebLogic community and a lot of the Kubernetes and cloud-native world. Helidon is another recent platform that's been built, and it's a kind of a lightweight framework for helping to build Java applications in a microservice world. And we have a bunch of sessions today around different technologies that are like Helidon and include Helidon, et cetera. And what you're trying to do then is provide a way for folks who are running Java already to map on top of Kubernetes, for example. And we have the group that I run, cloudnative.oracle.com. We have a bunch of blogs and code snippets and solutions built around how do you run Java applications and microservices built on Java within the cloud-native world using Kubernetes, for example. So another example of how you take a Java set of technologies and move them into this next generation world where it's a win-win on both sides. I can use Java in the context of things I know. Another exciting development, we're about to open source or release a Kubernetes service broker that's going to allow you to connect into our Oracle Kubernetes engine and bring in applications such as the autonomous database. So if you're developing a new application, a cloud-native application, using our new autonomous self-driving database, you can now use Kubernetes to hook that in and use all the Kubernetes orchestration cloud-native goodness in addition to automation provided for the database itself. And once again, database world brought into the cloud-native world using automation as a way to bridge the gap here. And the service broker provides a way to map those two worlds together. So look for that. Their release is coming out, if not this week, next week, I think. So the other big and, as we're talking about being inclusive, is bringing the on-prem world and the cloud world together. And as part of OCI, the Oracle Cloud Infrastructure, we've done a lot of work with the Linux cloud team, too, the Oracle Linux team. And they have a cloud-native stack they can run on-prem, which almost mirrors the stack that we're running up in the cloud. Same type of Docker, Kubernetes, and set of cloud-native stack technologies. And this provides a way to run some really cool use cases that we're seeing customers take advantage of, where they're, for example, maybe developing in the cloud but still running on-premise, or maybe they're developing on-premise and running in the cloud, or they can move back and forth in a bi-directional way. Another key use case we've seen several guys take advantage of just over the last few quarters is running high availability or your disaster recovery site up in the cloud. So you might be having an on-prem environment where you're running your day-to-day application, your production apps, but you want to run HA applications up in the cloud and have that as your disaster recovery site. Then you start getting into some really cool, sophisticated opportunities where, based upon compliance or regulatory or specific use cases, I want to run my workloads based upon those criteria. And once I have a platform that's running cloud native here and cloud native there, that's Kubernetes certified, so I have certification on both sides, and I'm running an open source environment that can move back and forth. Now I have the opportunity to automate that and federate those worlds. That's a little more sophisticated with intelligent orchestration and federation, and it's a little more progressive, but the technology's there, the use cases are there, and you're seeing a lot of people beginning to experiment with how do I begin to selectively move my workloads or run my workloads based upon use case basis. So we talked a lot about that cultural change then, of how you bridge the gap and provide on-ramps into cloud native. Second thing we want to look at is complexity. And if over the last few years, a lot of the only choices you had as a development team is to learn all the cloud native computing technology yourself, right? You had to do it yourself, you had to learn it yourself, and that was the only choice. What we're starting to see now is managed services have now been released by all the cloud providers. Managed Docker services, managed Kubernetes services, they're all certified Kubernetes. So now you have a choice to run, instead of doing it yourself, a managed service that can be run almost anywhere across any cloud provider. And teams that have been doing it themselves are now saying, I don't want to be a Kubernetes expert anymore. I'll just let you run the masters, the etcd servers. I'll let you do all the HA and all the distribution, and I'll put my application on top of it. So the core developers that have learned it already are leapfrogging into this world. But more importantly, it also opens up for everyone else who maybe hasn't learned all that stuff already, and there's a training barrier, a learning curve issue to move into managed services much more quickly. It gets you into cloud native in a much more efficient way. So, this is like the cloud native computing foundation landscape. It's almost too hard to put on a slide anymore. It's become an interactive model. It's almost a meme in and of itself. It's great that we have all these technologies, but with the good comes the bad. And there's a lot of choice, a lot of complexity. So, okay, go figure it out. Just run this. And that's really not the way we want to look at the simplifying complexity. So what we've seen in the past is the customer has had no other choice but to manage all that stuff himself, maybe running on top of a cloud environment, but still doing all the scaling, the HA, the backup, the release management, doing it all yourself. In a fully managed environment, you just focus on the app management and the app deployment, right? All the scaling, the patching, the upgrading, running all those masters are not things you have to worry about. This is something that we provide as a cloud provider. And you have choices to do this across multiple cloud providers. The best example I could say is that, instead of having to stand up your own Kubernetes and run that yourself, having the cloud provider do that for you makes so much more sense. It's a non-trivial thing to do. There's releases every 3 months. To get high availability and to run it across those environments is very difficult. All the cloud providers have made changes now and have put out releases and new services based upon a managed Kubernetes environment. They're all certified, and they provide choice, and they provide a managed service so you don't have to deal with that complexity. You can leapfrog through the training issues and those learning curve issues and go directly into a managed service. In addition to Kubernetes, which is our foundation, we've also released a bunch of Oracle Cloud services that are cloud native. We have a registry, a Docker V2 compliant registry that supports that. Resource Manager is a cool one. It's very recent. It's Terraform, the open standard Terraform as a service. So another automation opportunity. So Terraform as a service. A lot of people are starting to use this as a way to automate the whole capabilities. That just recently came out just a month or two ago. Oracle Functions, we had some discussion about the FN project, the open source FN project and Oracle Functions. That's in limited availability now. We'll have a bunch of sessions about that over the course of today. I highly recommended to learn more about the FN project. Serverless is a huge next kind of project for the CNCF to figure out, because if you think about containerization, talk about Kubernetes, there's been a lot of standardization. Right now, there's been everything around serverless is fairly proprietary. We have events in the new cloud event standard, which is now part of kind of CNCF, and that's the way services and serverless projects can communicate together by an event-oriented approach. That standard is there, so we can kind of begin to standardize how things can integrate. And we have an event service that's based upon that too. We also have a streaming service, pipeline, CI/CD, monitoring for telemetry, notification for hooking into things like PagerDuty. So this whole stack of orchestration, provisioning, application development, but also observability, all those things are critical as you're building out a full production application. You kind of start here and you work your way up, but you'll need all these things as you go. And these are all rolling out across the community as managed services. So the final thing then is we talk about inclusive, talk about being sustainable. The final kind of pattern is really staying open and staying true to being open. And by having a DevOps-driven culture, by having open source-driven code, really you're trying to find a way not to be locked into a cloud provider. All those things should provide no lock-in. So a single source, a single cloud provider strategy kind of locks you into their APIs. A multi-cloud approach is much more conducive to the DevOps and open source world that we're seeing going forward. And it's really why eliminate the choice when open standards enable choice. You can go on-prem, you can go in the cloud, you can go multi-cloud. You should be able to choose what your business needs. And this is the logical kind of end as we look at the process we're going through with the cloud-native computing technology sets, DevOps technologies, is having a much more flexible model and a choice-driven model around cloud providers. So open standards really make this something that supports not only modern cloud-native tools, but traditional tools too. We talked about a lot of those, and you'll see a lot of sessions today related to all these different sets of technologies. It enables integration naturally because they're built on a common set of frameworks that are standards-based, that are driven by a standards community. So the plug-in ability and the integration kind of comes second nature. It's built into the DNA of these applications that are being used. So that kind of wraps up the transition here. We talked about culture, code, and cloud. We talked about the issues around cultural change, around complexity, around single cloud lock-in, and then how you become more inclusive, how you choose a more sustainable strategy, how you focus on being open to drive choice. The next step is like training, learning, growing. You're in the right place. You've come to the right place. This is the right place to be for learning and communicating and building a community around what you do. There's lots of stuff available for the CNCF. LinkedIn has a whole bunch of Kubernetes topics that some of our team have put together that's available. Meetups, I mentioned that before. Meetups are a great way to build relationships locally and learn. A lot of the DevRel teams and the vendor teams come through all the local areas. And if and we spend a lot of time in our developer relations group just going to local meetups and talking and meeting people. And it's probably one of the most effective ways to organically talk about and learn about what's going on in the marketplace. CNCF recognizes that scary open source ecosystem slide is scary. So they also built out a trail map of kind of how, what's the garden path to go through as you actually navigate through cloud native technology sets. We have a lot of resources available at the cloudnative.oracle.com site and developer.oracle.com too. Lots of information, lots of DevRel services available from us, Oracle, but also from other sources too that I'd highly recommend. This is an example of a lot of the integrations that we've actually built solutions for in the cloud native team. So you can see things from streaming to CI/CD to monitoring with Grafana, to Terraform, to Kubeflow for AI, running AI applications on top of Kubernetes, so TensorFlow applications. So that kind of brings us to the end of the discussion. We kind of walked through the real opportunities and kind of the exciting things that are happening around culture and DevOps, that are happening around code, open source, cloud native technologies, what's going on with cloud and the power of the cloud, and also some of the challenges of how we open up cloud native for more solutions to go forward. So this next second wave of cloud computing and cloud native computing kind of brings more people in. We get more technologies and more software teams that can leverage it. I encourage you guys to enjoy the day, learn more about these technologies, and thank you. That wraps up my presentation. So.
Thank you very much, Bob.
Thank you. Thanks. Sure.
So, we're wrapping up. Just quickly before we let you go, a couple of announcements and housekeeping. First, we would like to tell you that Oracle Database 18cxe is released for Windows and Linux. That's our free Oracle database for development that you can download and start working with. Just head over to oracle.com/xe. Also, if you just want to get started with SQL without having to install a database, either learn SQL or just a scratchpad, or even just share some SQL scripts with your colleagues or friends, you can head over to livesql.oracle.com and you have a fully browser-enabled SQL scratchpad on the latest Oracle database technology as well. Java 12 just released about 3 weeks ago, I believe. So head over there. We have 16 new GEPs in there. We have new flight recorder security events, better HTTP and HTTPS support, and also update for the Japanese era. If you have customers in Japan, they just changed the time zone stuff there. And if you want to know how to become this cool new Groundbreaker, everybody can be a Groundbreaker, as you hopefully now know after the 2 keynotes that we had. Head over to developers.oracle.com where you can find out about all the technologies that you have seen today. Also, I apologize, that's my timer telling me that it's time to come up on stage. Also, we have voting up right now for our Groundbreaker Award, so we pick well-known people out in the community and open up of who should get a Groundbreaker Award at Code 1 this year. And it's up to the community, to you people, to vote for them, so you can do that on developer.oracle.com as well. We have SIP Labs Challenge going on. SIP Labs are 15 minutes hands-on labs that you can sign up over there in the Groundbreaker Hub. And whoever completes the most can win Rebound Tag that you can program and put on your suitcase or backpack to never ever lose your suitcase or backpack again. So check that out, head over there. For the entire event, we have a mobile phone app called Oracle Events. Just head to the App Store or Play Store, download the app, and then just search for Oracle Code Berlin, and it will have the agenda and everything on that's going on today. If you are on Twitter, I've already seen a lot of tweets out there, thank you very much. Please tweet with hashtag Oracle Code, tweet with hashtag Groundbreakers, and follow the Oracle Devs Twitter channel as well. We have an AR charity going on just over there. Maybe you have seen when you came in, everywhere you will find little signs that say AR Charity Challenge with QR codes. If you download the app and then scan the QR code, it will bring up a little quiz on your mobile phone, an augmented reality quiz on your mobile phone. For each right answer that you give, Oracle will actually donate $10 to Tech Innovate, which will help people to get started with technology. So certainly don't miss that. The stand and the leaderboard is just right outside the keynote hall. And if you want to sign up for Oracle Cloud, you can get free $500 Oracle Cloud trials if you head over to oracle.com/code19berlin or BER, or scan the QR code. Now, a couple of housekeeping things. Our sessions we will convert this room here into a session room. We have another session room, number 2, just right over there. Number 3 is up the stairs on the right. Number 4 is up the stairs and then again up the stairs on the very end. That's for the fitness junkies of us. And the hands-on lab will be right behind that room, also up the stairs, go there. Toilets, if you haven't found them yet, are over there to the left. And then here we have the Groundbreaker hub, where we have a lot of cool demos that you can check out. You can laser print your own little coasters for your wheat beers if you like. We have some really nice industrial laser just standing over there. We have the ER charity challenge going on, the blockchain beer not to forget, and many, many other things. And with that, I would like to thank you very, very much. Have a great day at Oracle Code. Vielen Dank, dass ihr alle heute hier seid. Genießt den Tag an der Spree. Super Venue hier und willkommen auf der Oracle Code Berlin. Danke.